simple basic challenge using public and private key cryptography, invented in around just after the Second World War by the bunch of Brits who kept it a secret because they couldn't see the commercial possibilities, reinvented by an American who made millions and millions and trillions of dollars and is the envy of all the other pure mathematicians that ever lived. Public and private key cryptography says if I encrypt something with one key, there is only one other key that can decrypt it, and it's a different key. And if I crypt it using that other key, I can decrypt using only the first key. Why is this useful? I want to send a message to RAF, and I don't want the rest of you to listen to it, but I want to do it over Wi-Fi. So if I just send it in the open, you're all going to hear it. That's not a good idea. So I'd like to send it as a secret. Now, Raf and I could have met out the back and exchanged a key and said, let's both use this key. That's fine if I'd met him. But I've never seen that guy. I actually don't even know if his name's really Raf. I just want to send him a message. But what he's done, which is really handy, is he's published one of those keys as his public key. And I use that public key to encrypt the message. Things encrypted with the public key can only be decrypted with the private key, and only RAF has the private key. So I can now send digital encrypted junk, and all of you can listen to it. You can all pick it up, but only RAF can actually decode it. So this is really useful in a world where we've never met each other, but we want to use cryptography in a directed fashion. Similarly, if you want to send me a message, use my public key. Everyone can hear it, everyone can see it, but only I can read it because you encrypted it using my public key. So far, so good. How does it work? Maths. It works with prime number work, and it works with the fact that you construct a really big number using two primes. Why is this an interesting problem? Because Euclid said, what, 2,000 years ago, the sieve of Eratosthenes, so it wasn't Euclid, it was Eratosthenes, that the only way you can take a really, really big number and actually work out its prime factors, if it's only got one or two, is to enumerate. 1, 2, 3, 4, and off you go. But if the number is 100 digits long, you're going to take forever. There is not enough compute on this world to do it. So the fact that that's a big number kind of works. Off we go, public-private key. This is easy. I'm doing something completely different. I hope that's okay. So the basic principle is that you raise a number to a power, and you rely on the fact that if I raise it to a power and then raise it to another power, n to the e to the d, the other way around. Public key, private key. Doesn't matter which order it happens, you still get the same answer. This is brilliant. Where do we use it? When I connect to the Bank of Akamai, which is a wonderful thing to connect to, I'm sure, what actually goes on is that I say, hello Bank of Akamai, I have a library, it's actually OpenSSL, and I can do RSA, ECDSA, and a whole bunch of other crypto things. Whatever is at the other end of that, and I have no idea, that comes an answer that says, here's a certificate, a digital certificate, and it contains some stuff, including the bank's name and its public key. I take that key and send a session key back, encrypted using the bank's public key. Only the bank can decode that. So at this point, we can then go into an encrypted mode where, because I've used the bank's public key that I think it's my bank, I now am pretty sure that I'm talking to the bank. So this is cool. It now says the only thing I really don't know is I've just been offered some digital gunk. It's called a certificate. How do I know it's the bank's? How do I know that's the right certificate? So why does my browser say you're cool? When you press on the green bit, you get a pop-up screen. Every browser does this. And this is the certificate that my browser got given. Down the bottom is a public key. It's RSA, it's 2048 bits. The certificate was issued by Symantec, and it was the Commonwealth Bank of Australia that got it. There's a lot of information there. And the thing that's interesting is that my browser likes it. This certificate is valid. Well, what's valid? Why did my browser like it? I could give it any old certificate. Will my browser say any old certificate's valid? In theory, my browser kind of knows the difference, yeah? How does it know the difference? So let's sort of unroll this a little further and see what happened. Commonwealth Bank generated a key pair. RSA, off we go, this is really cool. And they produced a digital thing called a certificate signing request. OpenSSL can do that, you can do one too. They then passed Symantec a large bundle of money. Not a few dollars, a lot more dollars. In exchange for a lot of money, Symantec issued a certificate saying this domain name and that key are the same because Symantec got money. And so if I can use the public key to connect to someone with that private key, I've gone to that domain name. I've not been intercepted. I've not been lied to because that's what the certificate is saying. This is cool. Who's Symantec? Because the way it works is that my browser unconditionally trusts Symantec. Now, it's not just Symantec and Apple. There are 700 entities that your browser and my browser always trust. Who knows Swiss signed silver? I don't. My browser loves them. Here's Symantec. Here's TrustCert. Here's a whole bunch of folk I've never met. And I bet you've never met them. But my browser says, if any of them issue a certificate, it's good. Because they never lie. Just remember that. They never lie. You can tell where this is going, don't you? Because at some point, trust becomes what we call credulity, idiotic trust, over-trusting. Because the real question is, if you look at this list, do we trust all of them? There's a really good blog out there from Google. It's a blog on security, and it's actually Google on security, right? If I did this same exercise using Chrome rather than using Safari, and I looked for the Chinese government as a trusted certificate entity, you wouldn't find it. Because Google doesn't trust them. Why doesn't Google trust them? Because, as explained very clearly, CNNIC minted a certificate for star.google.com. Oops. And it wasn't just they minted it, it was minted by a registration agent in Egypt. Double oops. And it was used on a man-in-the-middle attack to gain the passwords of Egyptian citizens trying to access Gmail. Triple double extra oops. Because your browser trusts them and they never lie, except when they lie. And when they lie about things you go to, you're a victim and you can't even tell. So some of the folk on this list are really bad. So just below CNNIC is Komodo. Oops, got hacked, badly hacked. Massive amount of press. What did they mint? star.google.com. Where did it get deployed? Over in Iran. What happened? People's passwords got hacked. This is bad. But my bank doesn't use either of those. My bank uses Symantec. They never lie. Never such an absolute word, isn't it? Never says there's no excuse. They certified example.com. I mean, they didn't even certify a real thing. They certified example.com with a real live, genuine production Symantec certificate. It's kind of, how did that happen? They didn't notice for 6 months. So they don't lie unless when they lie. And when they lie, they don't know they're lying. That's what I'm using as the basis of trust to access my bank. And you too might be going to someone who's certified by Symantec. We don't know about others. You don't actually understand to what extent this system's trustworthy. And some of the examples are pretty horrific because you get to be on the front page of a newspaper when it all goes wrong. This is the Komodo attack, and it was basically turned by the Iraqi government, so the Iranian government, to actually do a man-in-the-middle attack on their citizens and read their mail. This is nasty. We rely on decent encryption and a security infrastructure, and we're being let down. Why? Because when that certificate was presented to me, it didn't actually say the Commonwealth Bank really used Certicom. It didn't use Symantec. You shouldn't believe the Symantec one. It didn't say that. It said, here's a certificate used by Symantec. Because that handshake doesn't say which CA is the right one. And so you get this strange anomaly that is awesomely bad, that oddly enough, any certificate will do. I don't have to knock over Symantec to become the Commonwealth Bank. I can take any of the CAs on that list and get them to mint a certificate for Commonwealth Bank using my keys, and your browser will believe me because that CA is on the list. Here's the front door house lock of my house. It's a great looking lock, looks really secure. Yep, any key will open it. Doesn't matter. Just wave a key near it and the door will open. That's what you're using. That's the extent to which this system is awesomely bad. And because I can go to any CA, if you will, and mint a rogue certificate, there's no incentive for quality in this market. Every certificate's the same. If you're trusted, you're trusted. The browser doesn't trust some more than others. It's a single, do I trust these folk, do I not? And if you're trusted, everything you produce is trusted without qualification. So it's not a market that has quality. There are lots and lots and lots of folk who issue certificates. There are around 100 CAs, around 1,500 subordinates. There's a URL in the pack. Oh God, it's not online. I'll tell you where to find it. That actually gives you a list of all these. You've never seen it, met any of them. So many folk enjoy trust, it's just not right. So what wins in a market when there's no differentiation on quality? Because all the things that you think are going on aren't. It's only money. It's only money. So cheap wins. This is really bad. So what do we do? So if money's the problem, why don't we take the money out? And so there's this initiative that has the support of the Mozilla Foundation, the EFF, a whole bunch of other folk. And basically, Let's Encrypt is a free, open, automated system that will just issue certificates for free. So if taking all the money out of the system makes it better, we're going to find out. If taking all the money out of the system makes it worse, we're going to find out. Because these guys are now the biggest CA around, evidently. They're number 2 going to number 1. Because it's free. So one option is you take the money out of the system. Google decided to do something slightly different. They use a thing called pinning. And there's a piece of code there, it's open code so you can see it. And what they say is the only folk who can issue a certificate for start.google.com is these folk here listed in the code. So it's pinning. So I can try and offer you a certificate if you're running Chrome to say google.com, and you will go, no, you're not these people. You're not one of them. So those poor Iranians and Egyptians that got hacked were using Explorer or Safari. They weren't using Chrome because Chrome does pinning. And that doesn't mean go and use Chrome because in every other domain it's just as bad. Why? Because it's not completely insane until you realise that's a list. It's a list of domain names in the CAs. Is your domain on it? No. Is mine on it? No. How many domains are out there? Hundreds and hundreds of millions. Are they ever going to be listed in Chrome? Of course not. So it's kind of Google saying, well, I'm all right. The rest of you, yeah, sorry, we're not going to save you. So insane. The other one is, of course, this well-known adage in IETF circles, well, I'm not sure it is, that it had nothing to do with rough consensus and running code. That's just rubbish. No matter what the problem, put it in the DNS. Because the DNS is magic, the DNS solves everything, and it'll fit. No matter what you're trying to do, the DNS is the answer. And oddly enough, it works here. Because if I want to know the public key I should trust for my bank, and I ask the DNS for the IP address of my bank, why don't I ask the DNS for the public key of my bank? So why don't I just put it in the DNS and look it up as well? What's this certificate business anyway, when I could just do the whole thing with the DNS? So I could do a number of things now because the DNS is truly awesome. It'll do anything. I can put in the DNS only Symantec is the CA for combank.com.au. If anyone else offers you a certificate, that's bad. So I could just simply do that. And that's pretty simple. So I could try and pin it that way. I could try and actually do a hash of the certificate that Symantec issued. That issue a certificate, I could say, this is a certificate TLS should be presenting you with. Trust no others. Yeah. I could do the hash further down, or I could just go straight to the key. Give me a key, DNS. If this matches the key I'm being presented with, yeah, that's good. If it doesn't, that's bad. So at this point, things start getting pretty weird, because I can put something in the DNS for free, whereas even GoDaddy that sells me domains for $10 a year wants to sell me a cert for $75 a year. They're selling me something that's completely useless that anyone can lie. Why should I pay that? It just doesn't make sense to have CAs anyway. So the IETF, I don't know, someone must have annoyed, the CAs must have really annoyed someone, because the IETF spun up a working group and they produced this standard called DANE, DNS-based authentication of name blah, 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 blah. RFC 6698. And it kind of says if you want security in the DNS, why not use the DNS? And in some ways it makes a huge amount of sense. It's entirely logical. And if you read that one, you should read this one as well, because as usual, technology's never easy. We had second thoughts. This is cool. These are the examples, and they're actually really easy, because what you do in the DNS is to say, port 443, that's HTTPS, using TCP, for example.com, when you're using TLS, maybe the key you're getting should have this as its hash. Check that against the DNS. If you're not given that key, you should be worried. So these are examples of TLSA records that do certificate hashes, end entity certificate hashes, or even trust anchoring. So I got really engaged with this, and I thought, I can do this. I can do this. I can go to Let's Encrypt and get a certificate. You can too. It's called CertBot. Download CertBot and run it, and you've got a certificate. It takes about that long. Really simple. And you go, well, okay, I want a TLSA record. If there's no problem that can't be solved with the DNS, then the only other tool you ever need on the internet for anything is OpenSSL. It is truly the Texas Chainsaw Massacre of tools. Anything that can be done, OpenSSL will do it. Generate me a TLSA record, well, that's the command. You take a certificate, you simply say, produce a DER out form, transform it, OpenSSL into SHA-256, that gives me a hash, do a bit of cunting and printing, there comes a TLSA record, stuff it in the DNS. And you're kind of there. Out comes a well-formed TLSA, use a signing thing, and you're doing some DNS signing. Why are you doing DNS signing? Although there's another way of doing it. If you just want to do the signature field, the public key, piece of OpenSSL. Not hard. So now, with DANE, when I get that server cert, I can query the DNS. I can say, is that server cert genuine? I can check to see what I'm being given is what the DNS agrees with. And if it isn't, you shouldn't go there. So the handshake now has, I get given a cert, I go and check with TLSA records before I believe it, and you start generating a session key. Belts and braces. Except the DNS, in and of itself, is full of lies and liars, right? So unless you fix the security of the DNS, you've got a problem. How do you fix the security of the DNS? Well, you've got to validate. How do you validate? You've got to use DNSSEC. The beauty about DNSSEC, and in retrospect it was an inspired design decision, is that they avoided certificates. They just completely avoided all that gunk about certificates. The DNS is secured by interlocking keys. And if you're thinking, that sounds an awful lot like blockchain, you're there. This is a kind of blockchain that's anchored rather than relying on the ephemeral wisdom of crowds. It's anchored at the root. There's a key signing key. It signs over its own signing key. It signs over this. It signs over that. So this whole sort of recursive signing means that because you get something over here, you can check backwards to see if you believe it. Why? Because this will have a signature. You can check that it was validly signed by the zone signing key, which needs to be validly signed, and so on and so forth. It's simple recursion. Computers are brilliant at that. You only ever need one trust point, and it kind of works. So as long as you have the local trust anchor for the DNS, everything else just pops in for free. So now I query the DNS for the TLSA record. I get DNSSEC to validate it. I believe it. It's the real deal. So at this point, I know that the Commonwealth Bank is giving me a public key that they also put in the DNS, if they were doing this, that is the real deal. So why isn't this in my browser? It's really frustrating when you've got a problem and every single day another CA falls over and the browser vendor goes, not looking. I suspect that a bunch of CAs pay some of these open source browser folk to make sure they still have a life. And the browser folk, the open source browser folk, are going, well, if you're paying us money, obviously we're not going to subvert you. We're not going to go against your interests. Because for some reason, I need to go to plugins to make DANE work. And that is just really, really frustrating. And it seems that Chrome, for all of its care about me, doesn't care one jot about my security. It just doesn't care. Which is an awfully depressing kind of statement. They say, oh, it's the fault of DNSSEC. DNSSEC doesn't exist. Okay, so how much DNSSEC is out there? 10% of the world does V6, 15% of the world does DNSSEC. I keep on hearing V6 is around the corner. Any day now, there's a whole lot of it. There's 50% more DNSSEC. So don't tell me there's no DNSSEC out there. So maybe it's DNSSEC, but it doesn't even need to be. Because, again, the inventiveness of folk. Instead of querying the DNS for that TLSA record, the Commonwealth Bank could say to me, don't bother, Jeff. In that TLS handshake, I take all of the answers you would have got from DNSSEC queries and bundle them in to the package I give you saying, here's why you should trust this key. It's your DNSSEC root key. You can take that bundle and validate it using your trust. And if what you get back is an answer that you believe because you're validating it against your key, you can then take what's in the cert and say, this is really cool. Why aren't we doing it? I can't answer that. I get really frustrated when you see these kind of horrific problems in security of the internet and folk just aren't doing anything. The only evidence I could find is Richard Barnes. His name's here somewhere, Dave Keeler, and Richard Barnes have taken this on in the Mozilla Foundation, saying we're going to do DNSSEC, DANE, staple, TLS. I wish Chrome could see this and go, oh, we're going to do that too. So hopefully that's been more interesting than addresses. The basic message is it's one of those areas where we've really got all the elements of this technology in our hand. We can do it so much better. We can take bits of the DNS and DNSSEC and even marry it with the CA model if that's where you want to be, and actually create a system that reinforces each other and makes those horrific CA problems go away. That your browser's trust isn't absolute anymore. It relies on the DNS and DNSSEC to reinforce that. You won't get fooled by lies. So how simple is it? I did it. I did it in an afternoon. I'm not the brightest one in the crowd. It is actually not hard at all. And it didn't cost me anything because Let's Encrypt is free and all the rest just happens. So yes, it is readily possible to do this at any scale you like, whether you're a single web person like me or whether you're a massive web farm. Because all of a sudden now, with DNSSEC and Let's Encrypt, the tools are there and they don't cost anything. So you too can actually create security that is good, better than anyone else and better than my bank that's good for free. All I want is for Chrome to do it too. And then we could all do it. So hopefully that was more interesting because, like I said, I did addresses this morning and it's given you some insight into the current debates around security, DANE and DNSSEC. Any questions? Yeah.
Do you think that thousands of encryption servers over the world that are limited their response to like A or one day or 10 minutes records is the problem?
So the issue is, are there servers that will not serve TLSA records?
Some of them will limit the
You know, I'm surprised to learn that. I always thought I put stuff in a zone file and the server tells what's in the zone file. So if I put a TLSA record in and you ask for it, whoever is hosting my zone file will give you a TLSA record. They will give you the DNSSEC credentials. They will give you the DS records. And so the real thing is, have I been able to DNSSEC sign my zone, and do the people, the parent, so I'm doing potteroo.net, does the registrar accept my DS records?
I see from the other side from my over. And what I see is I travel all over the world. I'm connected to so many access points, recursive servers, and then I have a problem with them.
So let me go back. Let me go back to this slide. Because if you do it with stapling, there's no DNS queries. There's no DNS queries. You queried the DNS for combank.com.au and you got back an Akamai address. And then the Commonwealth Bank, via Akamai, sent you a bundle, including a bundle of DNS responses that you would have got if you'd have bothered to ask the DNS. At this point, your browser uses its local copy of gadunk, 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 this key here, because that's what you need, just that, and it validates it. No DNS. So it doesn't matter whether resolvers do or do not respond. If you use stapling, it comes for free. Brilliant piece of work. You know, top marks to Melinda Shaw and that crew. I love it. Check the draft. It's really cool. It's now a TLS working group draft. I've forgotten its name, but if you do DNS data track, IETF data tracker, it will tell you. Elaine. Yes. this being recorded? It probably is. No, I'll be honest. You've taken the time to be here and I'll talk about this. When we looked originally at the design of RPKI, we looked very, very hard at the design of DNSSEC. And what was attractive about the design of DNSSEC was no certificates. We thought that the certificate system was a huge overhead, but we couldn't see how to sort of move in the DNSSEC direction with trying to secure addresses and AS numbers. We couldn't see it. So deliberately, we decided to go down a PKI structure. In retrospect, and you can always have second thoughts, there was another way of doing this, and it had been thought about for a couple of decades. But what it relies upon is that if you go down into the reverse space in the DNS, the inadra.arpa, that takes addresses and maps them to DNS resource records. You can do a very similar thing to this in the inadra.arpa space. Nice thought. How well managed is the reverse DNS space for addresses? It's an absolute trash heap. It's horrible. If we wanted to do this, we have to clean up our act and we have to repopulate that reverse space in much better ways than it's being populated now. And we've got to really think hard about V6 because that becomes a challenge. Is it possible? I'd like to think it is. If we did it, would it be better than a PKI? Wow, I think it could. Because this certificate stuff is indeed a nightmare. The whole issue around trust and propagation. If you put it in the DNS, magic happens. Literally magic. It's so fast, it self-maintains, it's a distributed database that we seem to be able to stuff stuff in at astonishing volume and speed, and it just works. So it's so tempting, Elaine, to rethink the entire RPKI in reverse DNS. It's so tempting. And, I don't know, maybe I will. I just don't know, but I think it's worth the thought because the RPKI is giving us a lot of trouble. Raf?
I got two questions.
Jim?
In your example, when you actually hit Akamai instead of Compact, the TLS sessions overlays at the Akamai build, right? And then actually Akamai is CSX.
So hang on a second. There's bits that I know and bits that I don't know. I send a packet to someone who's using an Akamai address. Magic foo happens, or maybe not, and back comes almost a preordained packet that has no compute. I send back something that relies on the public key. Now at this point, Akamai need to access the Commonwealth Bank of Australia's private key. Or it's not the Commonwealth Bank of Australia, it's just Akamai having a good day. Now, I don't know the magic that gets from there to there to be used to pull that session key to get into the crypto. Now, I suspect that the Commonwealth Bank don't trust Akamai. Like, they're nice people, but they're not going to have my private key. So I think, no, private key to decode that session key, because I encrypted it with the public key of the Commonwealth Bank of Australia. So I need the private key of the Commonwealth Bank to unlock that. And I back end that goes, hi Commonwealth Bank, decode this puzzle, and it comes out back over again.
So basically, the Commonwealth Bank gives them a session key so they can see the session, but Akamai doesn't have the private key.
There's a blog by, oddly enough, Cloudflare about how Cloudflare solved the very problem for the banks. And I would not be surprised if Akamai for the Commonwealth Bank is doing something similar to what Cloudflare do for their customers. And it is indeed magic around here in picking apart that session.
So the other is I really love the idea of just not using CA that goes for the non-key plus DNS. But the problem is, if I'm in the DNS resolution file, I can break that because DNSSEC is not mandatory.
Again, hang on a second.
Assuming the,
Hang on a second. We're not using the DNS. We're using DNSSEC. And again, this is the piece of gravity-defying excellence.
it is, I mean, I agree with you, but basically, if I'm in the DNS resolution path in the sense that I'm the ISP, my users using my DNS server, I can on purposely turn off DNSSEC.
I never asked the DNS. The Commonwealth Bank, in that TLS section, Akamai, whatever, has already asked the DNS over on their side. And they said, if you tried to validate this, you'd get this answer, this answer, this answer, this answer, this answer. And in fact, what you would get, right, and it doesn't matter who asks, because that's the magic of the DNS, you'll get all of these answers. And so the Commonwealth Bank says, stuff asking the DNS. Here's all the answers. Pre-delivered. Look, no DNS here. Pre-delivered. Get out your key and start unlocking. And if you manage to go up and down to up, it's good. If it doesn't, and you're not asking the DNS a single question, if there's a break, don't trust it. But it's unlikely that the Commonwealth Bank would send you a broken validation path, because that's just bonkers. And that's the beauty of it. It's astonishing with security. It doesn't matter how you get the information. As long as you can validate it, you can trust it. And this trick is, don't bother asking the DNS. It's the same information if I just give it to you, but it's your key. You're doing the validation, not me. It's really very clever.
It's only bypassing DNS completely, other than the first address resolution.
That gave me Akamai. That's exactly it. There's no other DNS involved. It is very, very clever. It is genius. I wish Chrome was doing this.
More than a TLSA, I want my certificate. I want
I
my...
want my key in there and I don't need a CA anymore. Chrome, where are you? Are you listening? Yes, Chrome. Hello, Google. Okay, Google, do this. Okay? Yeah. They heard it. What would be really worrying is if my screen said, we hear you, Jeff. Oops. No other questions? As I said, I hope that was more entertaining than a repeat of this morning's talk, so thank you. And if you wanted to hear what I was going to say anyway, it's recorded in this morning's talk, so you haven't missed anything. Thanks a lot.
All right, next up, we have Mike Burns from IT Trading. He's going to tell us lessons from the ITV 43 market.
Port.
Well, I don't have a VGA. I have one of these.
That's a display port.
Well,
The display port that goes into, no, you don't have a hole for it.
I didn't think I did.
You don't have a hole for it. So,
And I don't have a VGA.
do you have nothing in the USB stick? My laptop.
Yeah, okay. Oh, no, it's just a stick.
Oh, that's the
I thought you said you had one, sorry. Sure.
Well, actually, I think it's online.
Oh, it is on.
Unless you changed it.
No, I didn't really change it significantly.
All right.
Yeah, there we go.
Full screen mode. Put this in. Full screen mode doesn't work like that.
Yes, good, very good.
So up, down.
Right, gotcha. All right, thank you. My name is Mike Burns. I've been an IP broker for a long time, more than 10 years, and I'm here to tell you a little bit about the IPv4 market, maybe with a little emphasis on operations, things that you guys, technical guys, need to deal with. But first, we'll do a general brief review of the market. You'll find out what a broker does and why we know so much that other people really don't know. We'll talk about the ways you can get IPv4 today, learn how a deal flows, and then give you some information related to technical issues that may be useful to you. And then we'll get a little bit meta and look at some warnings and predictions, maybe suggestions for policymakers. So the market started prior to 2010. There really wasn't much in sense of transfers because free pools were still around. But there were legacy transfers that happened, and most of those involved spammers who were unable to justify their voracious appetite for addresses. But in 2010, there was a seminal event in the market when Nortel sold addresses out of their bankruptcy sale to Microsoft. It was a public deal, and that kind of took the lid off, and everybody became aware that IP addresses, had a value and were sellable. And prior to that, it really didn't happen. After that, basically, not too much was transacted until APNIC exhausted their general free pool. But in 2012, there were some early participants who were just buying up, millions and millions of addresses, mostly from Class A or /8 holders. But late in 2012, interregional transfers began. And this allowed us to tap the ARIN market for addresses and send them over to APNIC. And we brokered the first one of those in October of 2012. And since then, there have just been more and more of them, and with a net inflow into the APNIC region. As time went on, other registries exhausted, and RIPE created an interregional policy that in effect created a unified market between ARIN, RIPE, and APNIC for transfers. In 2015, ARIN exhausted, and that really created a pickup in the market because unlike the other registries, there was no reserve pool at ARIN for new members. So if you need them in ARIN, you got to buy them. Last year in Latin America, they began intra-regional transfers, and that's going to happen this year in Africa. So I've been a broker prior to 2010. I brokered legacy addresses. I was a loser to Microsoft in that Nortel bid. There were only 4 bids, received by the bankruptcy judge for that auction, strangely enough, but Microsoft did win. I've done over 350 transfers of brokered addresses in every combination from ARIN to RIPE to APNIC. We've got clients in 54 countries now. And I'm a resource holder, a legacy. I'm a member of ARIN and RIPE and a policy author. And unlike other brokers, I think I'm a network operator. I run a network in 70 cities in North America. So the broker has an important role in this very strange market because buyers don't talk to other buyers and sellers don't talk to other sellers, and there's no real place to go to find a list of sellers and buyers. And really, you have to, in most cases, use a broker. So the broker's the interface. He gets the information from the buyer, the seller, escrow agent, other deal participants, and of course the RIRs. He's trying to get a fair deal. He's not trying to get prices, even though brokers earn commissions as a percentage of the sale generally. Brokers don't really care about rising prices or lowering prices. They just want to get the deals closed. Brokers have to keep information private, and we help the RIRs. We help due diligence. If you're going to buy addresses, you're going to want to make sure that they're clean and they're owned by the seller. Brokers do document preparation, and if you're doing IP transfers, you're not likely to be doing, dozens of them. You may be doing a couple of them in your lifetime. Not familiar with the contracts necessary, so brokers assist in that. In almost every deal, a third-party escrow agent is used to hold the funds while the transfer is processed by the registries, and the brokers deal with those as well. Providing assistance, getting through needs analysis and renumbering. But the biggest thing brokers do is we find the other party. If you're a buyer, you need to find a seller, and there's really no place to go to do that. And likewise, if you're a seller, you want to find buyers. And brokers are the best place for that. So today, there are ways to get IPv4. Everybody's familiar with policy-compliant transfers processed by the RIRs. Within region, between regions, those are pretty straightforward. You can also purchase an entity that has IP addresses that they're not using. You can do leasing, which is a way to acquire addresses without necessarily doing a transfer, and that has implications, obviously, for whois accuracy. There are still legacy sales of addresses, which are completely legal because legacy addresses don't generally have a contract that requires adherence to policy. There are some large deals involving options where buyers will want to reserve addresses that they might or might not need, and so they pay the address holder a certain amount of money to reserve those addresses for a certain period of time. Of course, there are reserve pools in some registries, such as APRICOT, where new members can come and get a /22. And so when we get inquiries from people for their first batch of addresses, we generally send them to the registries to avail themselves of these 22s. Of course, there are problems with these reserve pools with new members being spun up strictly for the purpose of acquiring these addresses. And then there's out-of-region registration, where people try to go to Africa, create a company there, and try to tap their free pool. Or for policy shaping, for example, in Latin America, you can only buy addresses that originate in Latin America, and there are not that many for sale. So some Latin American buyers choose to register in RIPE because their policies are more friendly towards that. This is the way a basic deal works. Non-disclosures assigned. Generally, the buyer will then do some due diligence, make sure the addresses aren't blacklisted. Price is negotiated, an agreement is signed. The agreement just requires a third-party escrow agent to hold the money. When he has the money, the seller initiates the transfer. Registries process the transfer. When whois is updated, the escrow agent knows he can send the money to the seller. If that doesn't happen and the registries prevent the transfer for one reason or another, the escrow agent returns the money to the buyer. This is very rare. Out of 350, we've only had one fail for lack of justification. Now we're seeing more and more leasing. Leasing is not really addressed in the policies of the various RIRs. It's not really spoken to. It's not prevented. It's not encouraged, but it does happen. And sometimes it's invisible to whois, but other times the lessor will create an entry, a SWIP in ARIN, or an assignment record so that the contact information of the person who's leasing the addresses will be listed in the appropriate whois, and so then any abuse can find the proper party. Generally, the lessees will get a letter of agency. So when they go to their ISP and they say route this block, the ISP looks it up and who is and says, wait a minute, this doesn't belong to you. And so they get a letter from the registrant allowing them to route the blocks. And that's generally good enough for most ISPs. The problem with leasing is spammers. So spammers are out to lease addresses. They're not going to say they're spammers, but they're only going to lease the addresses for 2 or 3 months. They're going to get them blacklisted, and then they're going to stop making lease payments. So generally there are different lease rates from mailers. It's generally about 3 times as much for a mailer as for a non-mailer to lease addresses. Current rates are around 50 cents per month per address for a long-term lease. Geolocation is something that's, that buyers are always interested in. You know, they're going to buy addresses from North America and they're in Malaysia. You know, how's that going to work? So that's one of the things we brokers have to do, educate the buyers, let them know that the geolocation, it doesn't matter where the addresses are registered, it doesn't matter what's in WHOIS, the country code. Really what matters is that the geolocation database providers, Maximind, Google, are updated. So once the transfer happens, the buyer has the addresses, then the geolocation databases need to be updated, and they all have provisions for that to happen. This was a problem in years past, but recently these geolocation updates are happening more quickly, and it really does work. So even if you're doing an interregional transfer, obviously there's issues with Netflix not showing movies, or you're getting the wrong language. However, if you give it a little bit of time, the geolocation updates really do happen. So if you're going to buy addresses, we might want to figure you're going to have a week or 2 waiting period before you can actually deploy them in your region, just to make sure that they are properly geolocated. So there's hijacks, and again, it's mostly spammers. So if you're a seller and you've got available blocks, you might want to consider keeping them advertised, because if they are advertised, it's a lot harder to hijack them. An ISP is less likely to accept a fake letter of agency and advertise addresses if they're already present in the table. However, there's a flip side to that. You know, we have a lot of sellers are legacy holders who got addresses 20 years ago, and many times the addresses haven't showed up in the table for 20 years. Now if they pop into the table automatically, you'll find that the spam houses of the world are on alert for this and will, kind of as a precautionary measure, list these newly appearing blocks. So if that does happen, you have to, often with the broker help, contact spam house, inform them of what's happening, and basically get it delisted. Some things to help with that are obviously keep your registry records up to date and make sure your domain doesn't expire, because hijackers will snap up that domain and then try to utilize that. There's another type of hijacking, which is registry hijacking. So normal hijacking is done by snowshoe spammers. They want addresses. They want to use them to send spam. That's their incentive. But registry hijackers are looking to acquire title to blocks in the registry for the purpose of selling the blocks and making money that way. So this is a very difficult situation, and it's growing more difficult because nobody likes to have these blocks unused, sitting on the shelf, dormant, embargoed, because of their status as being essentially unclaimed. However, registries can allow people to come in and make these claims and, take addresses, take control of addresses which may not really belong to them, because it leaves the registries in a sort of a legal predicament. So this registry hijacking is bound to become more and more common as the sources of addresses to sell are sort of drying up, and so there are many people actively investigating who is and doing the research on these old blocks, and they use the Wayback Machine or archive machine to go back in time and look at the way the original registrant, ran their company, maybe steal a logo or something, and then apply to Aaron as the owner of the block looking to claim the block. That's a real difficulty because it's hard to establish rules given all the situations and who is where legacy blocks were allocated to individuals, trade names, fictitious names, you name it. It's a real difficulty. There is some argument that this kind of registry hijacking could actually be a victimless crime in the sense that it will bring addresses that were, as I say, embargoed back into use and put them in the hands of somebody who has generally a justified need for the addresses. The registry hijacker will take title to the addresses and turn around and sell them to somebody who's generally a network operator. So in this case, you have addresses that are moving from never being available to actually being available. And of course, that might happen at the expense of the original registrant, but many times those original registrants are long defunct or even dead. So it's interesting, but bound to happen more and more. So these are issues that happen in transfers. Many times sellers are quite unsophisticated. Many times sellers are selling addresses which were acquired by a company that acquired another company 20 years ago. And they have no idea how to access, RDNS entries, old SWIPs or assignments. And, generally they need to be cleaned out prior to the sale. But they can also be cleaned by the new owners after the sale. But then there are leftover routes. Many times, you'll find you sell a /16, and after the sale, you'll find that there's still a /24 being advertised somewhere, which was an old client of the seller. They're no longer using the addresses, but the advertisement stays out there. And in that case, you have to contact the network operator with the AS who's advertising the addresses, and you've got to send them the documents and tell them, stop routing. So that can take a little bit of time. But interestingly, of all the registries that do transfers, RIPE is the only one who checks for these things. As part of the transfer process, they do look for routes and assignments. Dirty blocks. Well, there's a lot of transfers that do involve blacklisted blocks. So generally, they're worth about half of what a clean block would be worth. But, we know there are some buyers who don't really care. If I'm a residential ISP, I don't want my customers running mail servers anyway, so really doesn't care if they're blacklisted. But in terms of the value of the addresses, sellers and brokers do know that clean addresses are worth more, and so they're going to go and try to get them cleaned prior to the sale. So when they come up for sale and they're still blacklisted, that means that they're really dirty. Generally, they've been listed and delisted a handful of times. And there are no guarantees that you'll be able to get a block delisted after you make a purchase. Although, in general, that does happen. And if, if the buyer's Apple computer and they buy a blacklisted block and go to Spam House and tell them or ask them to delist it, of course it will be delisted. But the spam houses of the world are aware that this kind of cleaning via transfer mechanism is often employed by spammers themselves. So they'll transfer to another spammer and get it delisted and then start spamming again. So in general, if this happens once or twice, that's about all you're going to get in terms of getting delisted. You have to remember there's no leverage against the spam houses of the world. They fly by their own rules. So we have seen cases where they will not delist. There are cases where Spam House does not want the original spammers to see any kind of remuneration or pay for their for their performance, and they just refuse to delist. There are other blacklists as well as spamming blacklist. There's, for example, a policy blacklist at Spam House, which is where you can voluntarily list your blocks on that block list. If you're, again, a residential ISP and you don't want any of your customers sending spam, you can register them on the policy blacklist. But if you're going to be a seller, you should get rid of those before all sales. Like I say, some buyers don't care, and they're actually actively hunting for dirty blocks. You know, we've got some buyers who are web scrapers and others who really don't care about mailing, so they're looking for a bargain. So prices, you know, most people are interested in prices. Back in 2010, I was paying about $3 an address. In 2011, kind of Microsoft set the bar for a long time by winning that auction at $11.25. They really overpaid in that, as you can tell that the way prices went down subsequently. But largely they traded in that range, although smaller blocks were always more expensive because they required more broker time, and you know, it's just a general rule. We're seeing 24s around $15 per address in that size. And /16s now have really moved up, where they were 7 for many, many years. They're now 10 and higher. And there's an interesting side effect that leads to, you know, deaggregation here as a result of pricing. There are 16, you know, I'm a /16 holder, and I'm being told I can sell for $10. However, if I was to break it down into 24s, I could get $15. If I had the appetite for, you know, a series of smaller transactions, I can really make more money. So that kind of pricing incentive is new to IPv4, and it works towards deaggregation. Well, there are a number of unusual cases that happen, you know, over the years. For example, one that's quite common is we have /16 holders come to us and they say, you know, my technical guy says we're still using the /24. We can't really get out of that. Can we sell everything but a /24? And when you go out to the market and you say, okay, I got a /16 for sale, but just short one /24, you've got, you know, a 17, an 18, a 19, a 20, a 21, a 22, a 23, and a 24. That's what you have left when you take 124 out. You can't kind of put Humpty Dumpty together. And that makes it, you know, that makes it difficult. So we had cases where the seller of a 16 would say, well, look, just get me another /24. I'll renumber into that one, and then I'll have the full 16 available for sale. But if they're in the ARIN region, and they go to ARIN and say, well, look, I want to buy another /24, ARIN says, well, show me that you need it. And if they turn to ARIN and say, well, I also have a /16 I'm not using, they're not going to get approved even to buy a new /24. So there's, again, a case where the policy situation could actually, you know, incentivize deaggregation. However, I will say that ARIN has a workaround in place. So, you know, you can create a separate org ID and wink, wink, nod, nod. You can get that /24, and at the end, you can put it all back together again. We've had one buyer who really likes lucky numbers. I think he was Chinese. He liked the number 8, you know, so any address that we had available that had the numbers 8 in them, he was willing to pay extra for that, which I found unusual. We had a buyer come to us recently who was looking for the smallest number of digits in the address. Apparently, that impacted the bandwidth that he was required to send information, which I guess he sent a lot of information. So shortening the length of the address decreased his, maybe he was using satellite bandwidth, something really expensive, so he was going to pay a premium for the fewest digits. We had a situation where, you know, a company has been using a /19 from their upstream provider. And for many reasons, people want to have their own addresses. So they say to the upstream provider, look, I want to keep these addresses. I want you to transfer them into my name. And in exchange for that, I'll find another /19, and I'll buy that and sell that to you. The ISP said, okay, yeah, we'll do that deal. You know, maybe we'll get a little bit extra money for it. But when the deal tried to be put together, it fell afoul of the waiting period at ARIN. You can't buy addresses and then sell them without waiting a year. And so it didn't work out that there was a way we could make this happen in policy, to just kind of swap blocks as was desired. We had one buyer, don't ask me why, he wanted to buy just one. He was approved for a /14, and he wanted to buy 124 from each /8. Very strange. You know, we see plenty of cases where people come to us where, you know, they ran a mom and pop ISP 20 years ago. They never actually registered a corporation, or possibly even a trade name. And so they may have been, addresses may be registered to individuals. They may be registered to fictitious names. They may be registered to departments within organizations. And each one of those is very difficult and has unique circumstances in order to get those addresses viable for sale. We've had cases where in the early days, late 80s, for example, addresses were sent to representatives. Normally they were workers in colleges, and they would get addresses, and their job would be to disseminate those addresses to others in their region. But now some of these addresses were not disseminated. And so the individuals to whom they were registered in those days now are coming to us looking to see if they could sell off those other addresses. And it becomes a question of whether really they were actually address owners, or were they really proto-RIRs, you know, who were volunteers for early address distributions. You know, in the States, we have trade sanctions. There are, you know, several countries that are not able to do business with each other, and sometimes that requires working through a third country. And we've even had buyers come to us and insist on paying with credit card, which is hard to do. So I wanted to talk a little about carrier grade NAT, because it has a great impact on the IPv4 market. Really, you know, in terms of what is an economic substitute, it's the only economic substitute for IPv4 is carrier grade NAT. You know, we know IPv6, it just doesn't function that way yet. We've seen carrier grade NAT deployed by some ISPs in a transparent way to their users. So they'll just, all of a sudden the users will no longer have a real IP address on their cable modem. They'll have a NATed address. But for the very, very small number of users who might object to that, they offer an opt-out. So those users can still get a public IP address, you know, on their cable modem. In practice, that number is vanishingly small. 1 or 2% of users might notice that they've been switched to carrier grade NAT. So, you know, from my perspective as a broker, I think that carrier grade NAT works. It's obviously used by everyone every day. You know, there's 10 times as many devices on the internet as there are public IP addresses. So if you do static mapping of ports, you can easily get a 64-to-1 reuse ratio. And you can get far higher than that if you do multiple levels of NAT. So, you know, it's obviously a powerful impact on the transition to IPv6. If the real reason for the transition to IPv6 was exhaust of IPv4, if carrier grade NAT offers an address space effectively 64 times or 256 times bigger, you know, than the 32-bit address space, it kind of meets it answers the need for IPv6. And you know, it's unpleasant for us to consider that, but it's possible that carrier grade NAT could expand and expand and expand, including the Internet of Things, to the point where it could be a decade or more of IPv4. In order for IPv4 to persist, prices really need to be stable. We know if prices start getting up in $100 per address range, well, that provides a real incentive maybe to transition to free IPv6 addresses. But if carrier grade NAT allows more sellers to come into the market because they're imposing that on their customer base, and they're freeing up addresses and bringing them into the market. As IP address prices go up, that incentive to transition to CGN for those who haven't already is going to also increase, and that's going to lead to more supply. So it's really a delicate balance where carrier-grade NAT can both reduce the need to buy IPv4 and increase the supply of IPv4 available for purchase. So anybody who's interested in the market has to really keep an eye on IPv4 carrier-grade NAT. So, you know, just a little bit meta now as we go into the future, a couple of things and cautions that we see from the broker perspective. Obviously, as the supply of addresses has kind of shrunk over the years since the Microsoft Nortel deal, most of the Class A legacy holders, the /8 holders, they've kind of sold their blocks in big chunks. And so now the demand for addresses continues, and now the people who were buying /10s and 11s and 12s are now looking to bundle up /16s and meet their needs that way. It just means the prices are increasing, and as they do increase, the incentive for hijackings increases, as well as the fact that some of these registry hijacks, at least, are almost victimless crimes. So there's going to be also the danger that you know, the regulation and taxes will come into this market, and it's largely been free of virtually all government regulation. The IPv4 addresses that we move around the world are never subject to any taxes, and the regulations they're subject to are mostly just policy compliance with the policies of the various RIRs. The government agencies really haven't gotten around to noticing this, so you know, that's good as far as we're concerned. The less taxes and regulations, the more transparent the market is, the easier it is to move addresses around. But as prices do go up and as available addresses do go down, there is potential for corruption at various places in the ecosphere here. Inside the RIR, decisions are made that are worth millions and millions of addresses, of dollars. And we're leaving, you know, RIR staff members to sometimes make these decisions, and there's a potential for corruption. We see the kind of corruption involved in the plundering of these final /8 pools around the world, where, you know, people are spinning up entities and sucking down the addresses that were really designed for ISPs of the future. You know, listing agencies, Spamhaus, Barracuda, that listing has an impact on the price. And so, you know, it's worth a lot of money to get Spamhaus to delist a /15. It's worth hundreds of thousands of dollars. And, you know, when there's that kind of money, there's a potential for corruption. Inside the corporation, we see issues where old tech people are selling blocks that belong to an old, you know, employer without the employer knowing it. And obviously, we talked about the techniques that are used to drain the remaining pools. So looking into the future, we see prices rising. They started rising really in the third quarter of last year. This is the time when several large cloud providers began building networks in North America. And last year, they really couldn't get the millions of addresses they needed, so that's when they started really bundling /16s into larger packages to meet their needs. So that caused a run on /16s, and the increase in pricing, you know, really went all the way down to /24s at that point. We do think that interregional policies will continue to loosen around the world. We have a policy proposal in Latin America to allow inbound-only transfers. We hope that there'll be a global market, like a global internet, within a few years, where addresses can flow throughout every region. We kind of are hopeful that needs testing will fade as more evidence is accrued that there's really no danger of speculation in this market. There's no evidence of that in RIPE, where needs have been removed for years now. So look for policies that are intended to recover abandoned space. There's a lot of space out there that hasn't been contacted or hasn't had a live contact in 10 years. And so I think policymakers in the various communities will probably move towards doing some kind of contact validation and some kind of process where if contacts for a block can't be reached for a certain number of years, that eventually they became subject to revocation and reissue. We will see some niche markets. You might see an ISP broker who's wants to be able to offer addresses that are already geolocated in various locations. So, kind of a one-stop shop. You'd pay a premium, but you'd get addresses from the location which you desired. We may see, smaller than /24s, being leased. You can't obviously, route them, but you might see vanity ISPs. We sometimes get requests, like we all know 8.8.8.8. That's a very easy number to remember. And people do look sometimes for those vanities. We don't see any investment or speculation plays. Really, the IPv6 transition is so hard to time. It's sort of like the sword of Damocles over anybody who's looking to speculate. Could just end anything. And then there's a growing market for small blocks. Most transfers are smaller blocks. And we see a lot of companies who had 24s from their upstream provider, and they need a little bit more address space, and they can't get it, or they can only get it at exorbitant prices. So they're looking to become owners themselves. It also gives them flexibility to change ISPs. Some suggestions for policy in the future, things like needs tests, holding periods for resales, regional restrictions where, countries can't, where addresses can't leave a particular country, for example. Those should be phased out as much as possible. There are some countries that feel that they were shortchanged, in terms of IP allocations, and so they want to protect their regions by preventing outflow. And, we think that's kind of a dangerous situation. We like the borderless internet, and we'd want a borderless transfer market as well. The IPv4 market needs to show to everybody that it's working, it's functional, it's efficient, it's non-corrupt. There's always the threat that some kind of a governmental organization like the ITU could step in if there's a demonstration that the stakeholder-based internet is not governing itself correctly, and that's to be avoided. We like the idea that registries do recognize brokers, and in the case where in APNIC and ARIN and RIPE, brokers who get listed on the registry's website do have to sign an agreement, a basic agreement that makes sure that they treat the customers fairly. So I think we also have to just accept the fact that NAT, multi-level NAT, actually works, and it's something to consider in terms of, for example, there was a policy proposal here in APNIC to allow WHOIS to record a port range as well as just an IP address. So you might, if you're doing carrier grade NAT and you're statically assigning 1,000 ports to each customer, well, why shouldn't that show up in WHOIS? If you can do a WHOIS search by IP address plus port number, I think that's a good idea. And finally, some registries still contain in their contracts language that allows the registry to reclaim and revoke addresses for lack of utilization. And that's a real problem for somebody who's considering selling addresses. It's very scary to come up to a registry who has a contract saying you've got to give them back addresses you're not using and tell them I'm not using these addresses, but I'm not giving them back either. I want to sell them. So removing that language from the RSA agreements, we think is a real good idea. Any questions?
I know one. So as you mentioned in your slide deck, the origins of the broker ecosystem had
Yes.
So basically, how would one choose a good broker?
Well, I think it's you should first look to the registries that have lists of brokers, because at the least, you know, they've paid a little bit of money to the registry. They have to sign some kind of agreement that you know, calls for fair action. It's posted on each of the websites. So, at the very least, you should look for a listed broker. But I think, given the opacity of this market, how dark it is, that really what you've got to do is get references. Ask any broker that you're considering for references. And really, you know, if a broker's doing a good job, even though he signs a non-disclosure with his clients, we find that the clients are more than happy to provide references. And so, you know, we ask potential customers who are considering our service to inquire about a reference from their country. And then if, you know, in most cases we can provide that. That's an important thing.
So one of the responsibilities of the broker is to validate that the seller actually owns the block that he wants to sell.
Well, that's not actually a broker requirement. The due diligence is, it's risky. So basically what we do as brokers is we've left the due diligence responsibility to the buyer, although we assist in that. What's more, we leave the actual decision as to whether the seller is the actual rights holder to the registry. So that's up to the registry to decide, and that's part of what the registry does initially with every transfer, is to vet the seller as the appropriate rights holder. Sometimes that's easy to do, and sometimes it's not. But it's really not a broker's task, although we can assist in that. You know, there's chain of custody documentation, and but it's too fraught with peril for brokers to take that risk.
So as a buyer, how should we do it? I mean, especially for legacy blocks, which there are no clear ownership.
Yes. Well, for cases like that, the registry is going to have to see a chain of custody documentation before they'll ever allow any sale to proceed. So remember, the buyer, his money is safely in an escrow agent's hands. And if it turns out that that the chain of custody that's proffered by the seller is not accepted by the registry, the buyer can walk away from the deal. And so we leave that decision-making capacity to the registry, and we defer to them. And even if we think they're wrong, if they say, no, this guy is not the seller, we have to walk away from the deal.
In your experience, what's a rough percentage of deals that go sideways because of lack of documentation, or you know, it turns out that there was something that doesn't belong to them, go sideways for a reason?
Yeah. Okay, we've only had one deal fail due to the failure of the buyer to justify. However, I would say about 10%. About 10% of sellers come to us with some kind of an issue, you know, that needs to be resolved. Many times that's done via some like cleanup with the registry. Maybe we have to do an 8.2 or a merger and acquisition transfer, or a series of those to bring the addresses into the name of a currently registered entity that's capable of selling. But I would say about 10%.
But you haven't seen a case that the transfer went through and then it turned out to be fraudulent?
We've got one case like that, and it was a transfer of historical resources in RIPE. And they have a kind of an unusual policy for RIPE historical resource transfers. And in this case, they approved of a transfer. Fortunately, it was just a /24. And after, about 6 months after, RIPE contacted us and the buyer to say that another company was claiming those resources. So it's not always done like that, but it hasn't been resolved yet in that
How
case.
would someone like us, who are buyers, prevent that from happening?
Well, that is a very rare situation.
As you mentioned, there's going to be more and more.
Yes,
prolific.
yes, but I believe that you can rely on the registry's decision. You know, that they are the decision makers in this kind of process. And I don't think that RIPE or any other registry would renege on a transfer if it was a policy compliant transfer. However, this was a legacy. This was a historical transfer, and they have different rules for that. Yes, Jeff?
Yeah, you're talking about various points, compliance with the transfer policies of the RIR. As a thought experiment, if we ditched all of them and instead said price has to be open, it would look more like a stock exchange than it would do with this current system of would your life be easier or harder? There is no qualification crap, none of these sort of silly demonstrated need nonsense rubbish. It's kind of, if someone who has an address that wants to sell to someone else, the registries, as long as they satisfy the bona fides of both of them, say yes, as long as a public price is afforded.
Well, it's kind of a trade-off there. It means that, you know, as brokers, we can't kind of negotiate from a position of strength where we know the prices, but the other buyer doesn't. We know what the prices are for the 350 transactions that we've done, and several others as well. I would say, though, I would definitely make that trade. Brokers don't care what the price is. You know.
I'm just not observing the stock market works because of open pricing.
Yeah.
Yeah.
Yeah, I agree. I would like the pricing to be open, and I would like the registries to be no more than title agents, just recording the title, making sure that the title is held by the correct party.
Your life would be easier if we stopped doing demonstrated needs and stuff, et cetera, tenure, minimum holding time, et cetera.
Yes, I believe.
You expose the price, and that's it.
Yeah, I would do that. You know, none of the registries have even considered that, even as a thought experiment.
We had it
Oh, you did? You had the prices recorded.
because Aaron decided that what we were doing was way too fancy bad.
Yeah, well, they decided that about a couple of measures, right? You used to have no needs test at all, and then that was changed. I would say that, you know, we don't care about the pricing. You know, we don't really hide the pricing. If anybody, we don't post it on our website, but if anybody calls us and says, you know, what are your price for a 24, 23, we just quote them the price. There are a couple of sites that I guess do IP auctions, and they do list the unverified auction results. And we find the prices to be quite stable. There's not a whole lot of outliers in the market. But yeah, I would definitely make that trade. Although, you know, it might make our role as a broker a little bit less important because, you know, you don't have to come to a broker for the price anymore. And you don't have to come to a broker to kind of negotiate you through the policy hoops. No, that's right. But all in all, I would definitely accept that, you know, that trade-off. Anything else? Thank you very much.
Thank you. And that concludes our IP addressing session. So, yeah, we go into the next session.